This tutorial illustrates one sample t-test in SPSS. Here is the dataset. We have 30 superintendents. In the data, we recorded their age, gender, height, and weight, and their stress level. We're interested in age. Suppose the population, in the superintendent population, the average age is 50. And I want to compare the sample age with the population age to see if our sample is representative of the superintendent population in terms of age. Let's run a one-sample t-test. For t-test, go to Analyze, Compare Means, and go down to one-sample t-test. Since one-sample t-test is to compare a sample mean with a population mean. And the variable we are interested in is age, so put age into the test variable box. And in the test value box, we enter 50 because that's the population average age we want to compare our sample age to. Click on the options. The default looks good. I want the confidence interval at the 95% level. If you want to change the level, you certainly can. So for now, I just use the default, continue, and OK. And here is the output. The first table shows that we have 30 superintendents. Their average age is 48.8. And the standard deviation is 6.435, which is quite a big variation. And the standard error for the mean is 1.175. And that means if we take repeated samples, we would expect our average age to vary average by 1.175 years. The t-test is presented in the next table. The test value is the population average age. We compare our sample average to the population age, and we find that our sample is on average 1.2 years younger than the population mean. So we compare the mean difference in light of the standard error, the average sampling error. And so we got a t ratio. And that means just to see in terms of standard error, how the mean difference is how many standard error away from the zero, and the expected value, which is 0. So our t ratio computed is negative 1.021, which is if you look at the absolute value of the t ratio, which is not large, because we usually compare this with a t ratio of 2 if we have a sample size 30 or larger. So we know that we will fail to reject now. The degree of freedom is 29 because we have one sample. We just subtract 1 from 30. We got 29. And the sig, two-tailed, that's a two-tailed t-test. And sig means the observed probability value associated with this t ratio. That's 0.315. And that means if we take 100 samples of this size, we would expect a mean difference this large, like 31.5 times, if now it's true. So which is quite usual. It's not that unlikely. And that's also why we fail to reject now and conclude that our sample comes from a population that's quite similar to the superintendent population with regard to age. And the table also has a 95% confidence interval around the mean difference, which means that the mean difference is the observed mean difference from our sample. And when we compare this sample mean to the population mean. If we take repeated samples of this size, we would expect 95% of the mean difference would range in these two values. And this range, or this 95% confidence interval, contains 0, and that also means our sample mean does not differ significantly from the population mean, which means our sample is representative of the superintendent population. That's the end of this tutorial. Thanks for watching.